Hello everyone. In this video, we're going to look at potential energy diagrams and how to use these to represent the energy change of a chemical reaction. If we think of a general reaction, we know that we have our starting reactants that transform into the products. But to transform our reactants into products, an intermediate complex is formed. This is where bonds are partially broken and partially formed simultaneously. The intermediate has a high energy level and is therefore unstable. The intermediate is also called the transition state or the activated complex. Transition state is the term that we will use in our potential energy diagrams today. Let's take a look at the different components of a potential energy diagram. Along the y-axis, we have potential energy in kilojoules, and along the x-axis is reaction progress, which represents the reaction occurring over time. Now, our reactants have a certain energy level, and our products will have a different energy level. In order for a reaction to occur, there must be a change in energy, and the difference in this energy is the change in enthalpy, represented by the delta H. And this is the energy difference between the starting reactants and the final products. In order to get from the reactants to the products, we have to first go to the transition state. This is where the energy is at its highest level. The energy difference between the reactants and the transition state is called the activation energy. And this is the energy needed to reach the transition state. We need this minimum amount of energy for the reaction to even happen. So these are the different parts of a potential energy diagram. The difference between the reactant and transition state is called the activation energy, and the difference between the reactants and the products is the change in enthalpy. Now let's take a look at a potential energy diagram for an endothermic reaction. Our axes will stay the same, potential energy along the y-axis and reaction progress along the x-axis. In an endothermic reaction, energy is going to enter the system, which means our products have more energy than the reactants. When we draw this on our diagram, our products will have a higher energy level than the reactants, so a positive change in enthalpy. Then we can draw the reaction progression, and at the highest energy point is the transition state. This is where bonds are breaking and forming. And the difference between where we start and the transition state is the activation energy. This is the minimum energy needed for the reaction to occur. The positive delta H tells us that energy is absorbed from the surroundings. Now let's take a look at an exothermic potential energy diagram. We put potential energy on the y-axis and reaction progress along the x-axis. We know that in an exothermic reaction, energy is exiting the system, so our products will have less energy than the reactants. So we'll put our products at a lower energy level, and we have a negative change in enthalpy. Our reaction progress will still have us reaching a transition state, which is the highest energy level, and the energy needed to reach that transition state is the activation energy. So for our exothermic diagram, our negative delta H tells us that energy is being released into the surroundings. Thanks for watching.